So I'm going to talk about Apollo Client, which, as Sashko mentioned, we've spent pretty much all of the past year building. And I'm kind of going to try to take you through the journey of how we built that and of a few of the hiccups that we've kind of encountered along the way. And I'll see if we actually, I'll try to see if we actually achieved kind of the goals that we set out to do on this journey. So the first question you probably have to ask yourself is what is a GraphQL client and why do you really need one? Because isn't GraphQL like this great query language where you can just write a nice string and then you get wonderful JSON back from the server? What more do you really need, right? For example, isn't curl a GraphQL client of sorts? I mean, you give it a GraphQL query, you send it to a server, and it gives you back a GraphQL result. And in many cases, this is actually probably enough. We've actually seen people use Apollo Client for pretty much what curl can do. But when you're using GraphQL in the context of a web application, there are often a few more things that you want from it. So this particular client that we saw here, curl, is an example of sort of the plain fetch GraphQL client. And the advantage of that is it's really easy to understand what you're going to get, right? It's really simple. It's super predictable. And it only has one downside. It actually doesn't help you keep your UI consistent. It doesn't help you cache, for example, GraphQL requests, things like that. And so Apollo and Relay are examples of a caching GraphQL client. And kind of the advantage of those clients is that they help you keep your UI consistent. We'll kind of dive into that later. And they kind of help you manage the data in one place. If you've worked a little bit with React, you've probably used stuff like Redux. And so kind of that philosophy there is that you want to manage all your state in one place. Because if you manage your state in every individual component, what you're going to end up is a mess with lots of inconsistencies in your UI. You updated the data in one place, but then it's not updating in another place. I think you've probably all been to a website that did this kind of stuff, where you were like, oh, let me fill out this form over here, or let me do this thing here. And then you look at the UI, and you're like, well, here it says, here it says I made the purchase, but up here the number of things that I've purchased is still 3 and not 4, even though I've made the purchase. So that's one of the things about consistency. And basically, the only disadvantage the main disadvantage compared to a simple GraphQL client is that you actually have to learn something. So Relay is known for having a not super smooth learning curve. Apollo is also not as easy to learn as a simple fetch GraphQL client. But we're trying really hard to keep the learning curve super smooth and still give you a lot of the amazing features that GraphQL clients like Relay have. So let's dive into it. So when we started building Apollo Client about a year ago, we were actually looking at what the kinds of things were that we wanted to have in a GraphQL client. We initially tried to use Relay, but we kind of figured out along the way that it was pretty hard to adapt it for us because Relay's core was kind of baked in with it was kind of very closely tied with how React did things. And coming from Meteor, we needed to support multiple view layers, so other view layers like Angular or our own Blaze or Vue.js. And so we really, at that point, didn't have much of a choice but to build our own GraphQL client. So one of the things that we really wanted to emphasize in Apollo Client was that we wanted it to be community-driven, which means that we wanted it to be really easy for people to contribute. Because we learned kind of from experience with Meteor that the community actually comes up with a lot of really great ideas. And if you empower the community to contribute features to the stuff that you build, they're going to build things that you didn't even have the idea of building, and they're going to build some of the most successful and some of the most popular features in the software that you have. Now for Meteor, it was actually kind of hard for people to contribute for a long time because it was such a complex code base and it was relatively monolithic, which meant that people had to understand lots of parts to update even a single part. And so with Apollo Client, we kind of wanted to turn that on the head and make it simple for people to contribute. Another thing that was really important to us was to have it be incrementally adoptable, which means we didn't want you to have to throw away all the code that you've written in your previous app in order to be able to use Apollo Client. You should be able to just npm install Apollo Client, take one component in your app, add Apollo to it, or like add a GraphQL query to it, and then load your data in just that one component with GraphQL. You might notice that some of these are like slightly inspired by our experience with Meteor. So this second one is also kind of inspired by that, because Meteor kind of comes as one thing, and for a long time, you either had to adopt all of it or none of it, or at least that was the perception that people had. So with Apollo Client, we kind of emphasized from the beginning that it has to be really incrementally adoptable. The third one was to really be compatible with everything. So Apollo Client should do one simple thing, and you should be able to plug in other stuff with it. So if you wanted to use it with, if you wanted to use it with Redux, or you wanted to use it with Recompose, whatever, you should be able to do that. And if there's anything that we keep you from doing because we baked something into Apollo Client, that's a bad thing. The fourth one was really to make it simple to get started with. And this one was kind of inspired by Relay a little bit, because we found that it was difficult for us to kind of change the way it worked or to adapt it to what we wanted to do, because it had all those build steps. And so it required people to have a build chain and Babel and things like that. So by simple to get started with, we really wanted people to just be able to run npm install, import Apollo Client, decorate their component, and they're done, pretty much. Well, you got to build a GraphQL server, but you want to use GraphQL without having a GraphQL server, you're going to have kind of a hard time. So the fifth one was, and this kind of ties in with the first one, and the fifth one kind of ties in with the first one, which is we wanted it to be inspectable and understandable. It kind of ties in with the first one, because the easier it is for people to understand what's going on inside a piece of software, the easier it is for them to fix bugs or contribute to it. And so what we wanted to focus on was really kind of breaking down the components of a GraphQL client, or breaking down a GraphQL client to its most simple components, so that people could actually, for example, open the developer tools and look at what happened inside my GraphQL client. Because one of the worst things that you can have in your app is kind of a black box where you put things into, and then other things come out, but you have no idea what happened inside. It's great as long as it does exactly what you expect. But if it does something slightly different, and every sufficiently complex library will do something slightly different on occasion, then it's really good if you can actually inspect it and look into it. And this is also kind of something that we build for ourselves, because it's really hard to fix bugs if you don't understand what's going on inside your own library. And so I'll cover that point later, but we actually built developer tools for Apollo Client, and we have a store that's really easy to inspect. And the sixth one, which is in many ways the most challenging ones, is that we wanted it to be built for interactive apps. Now, what does that really mean? It means that we think the future of web development is going to be apps that are pretty interactive, right? We already had Web 2.0. You don't just go to a website and read something and then close it again. It's no longer static. It's very much dynamic, and it's also interactive. So users are going to open a website. They're going to click around. They're going to modify things. So they're going to update stuff. And while they're doing that, other people in other places are also interacting with that app, and they're updating state on the server, which you also want to have reflected on the client. So what we mean by built for interactive apps is that Apollo Client should make it really easy for people to build apps like that. And the seventh one, these are not strictly ordered. So we did not do all the 6, and then we realized, oh shit, now it's really big and inflexible. But I just had to put that on there somewhere. Basically, to keep it small and flexible, nobody wants to install a 2 megabyte data loading library. in their front-end app, especially not on mobile. And so we wanted to keep it relatively small and flexible. Right, so how do we do on all these points? I'm not going to try to bore you too much. I'll try to go through all of these as quickly as I can. But yeah, how do we do on all these points? I think the one point that we probably succeeded the most with, at least in sort of our own perception, is that we really succeeded in making it community-driven. And it might seem easy, but it actually takes quite a lot of effort to always be there and respond to GitHub issues, merge people's pull requests. If you've never worked on an open source project yourself as a maintainer, you might think that every time someone makes a pull request, the maintainers go yes, a pull request. I just have to click merge and everything will be perfect. It doesn't really work that way because every time you click merge, you're committing to maintaining a piece of code for pretty much as long as you work on that project, as long as the project stays alive. So yeah, so community-driven. We've been working on this for 12 months, and we've had a community of contributors from day one. We've had people building related packages, people making pull requests to Apollo client. For all the Apollo projects, overall, we now have 450 contributors. We counted this yesterday, and we wanted to make sure, I put a little asterisk there for the number. If you go to the Apollo client repository, that number is not 450, but we think it's really important to count pull requests to documentation as well, to count pull requests to libraries that are actually part of Apollo client, like GraphQL tag and GraphQL anywhere. So in this number of contributors, we just counted everyone who contributed to sort of the repositories that are under the Apollo org. We've actually, Apollo client just passed 3,000 commits. We've made 111 releases. I timed this really carefully from a few months out to make sure the number today was going to be 111. And I think we also just crossed 400K downloads, although take that with a grain of salt because NPM downloads are kind of a voodoo metric in many ways. But yeah, I like this graph here of the NPM downloads, and to make sure it looks like it's really growing even faster, I squeezed it a little bit on the x-axis. So I think it's pretty impressive now. I'm pretty happy with that. No, but to be serious though, I'm really humbled and honored to have worked with so many amazing people in the community who have all contributed to Apollo client and kind of made this release today possible. So Sashko already mentioned, today we pressed the button and we released Apollo client 1.0, which means it has no more bugs. There will be no more changes for all eternity, and everything's going to be perfect. No, but kidding aside, we published Apollo client 1.0 today, and we codenamed it Pink Panther. So. Really, none of this would have been possible without really the amazing community support that we had from everyone. And I really look forward to continuing working on it. So yeah, let me speed up a little bit in crossing off these points here, because otherwise I'm never going to get done. So we wanted it to be incrementally adoptable and simple to get started with. And so because no demo ever fails, I'm going to actually try to do a demo here of how easy it is to get started with Apollo client. Now, of course, the code is pretty small. Lots of thanks to the Expo guys, thanks to whom we are able to do this super simple demo here in the browser. So how easy is it to use Apollo client? So here we're using the React Apollo package, which we've imported down here. Sashko built this really cool example, and he put the imports all the way at the bottom because that's where we like to put them. No, it's just so that when you open it at the top, you actually see the code that you care about. But what we did is we import all the stuff from React Apollo here. And then what we can do with this feed component, which we'll see over here. Here we'll see a feed of GitHub repositories in our example app GitHub. So this is this feed component. And we want to get data into that feed component with React Apollo. And actually, all you have to do for that is you have to provide, in the context somewhere, you have to provide the client. So you do that by having this Apollo provider here. And of course, you have to initialize the client at some point. All you have to do is point it to the API, to the GraphQL server, where you want to send the query to. And then you wrap this feed component here with a GraphQL higher order component that you import from React Apollo. And this is what the higher order component looks like. You just say GraphQL. You give it a GraphQL query here. This little tagged string actually parses GraphQL and then turns it into a GraphQL document. So in this case here, we're getting a feed. We're just getting the top 10 of these things. And these are repositories on GitHub. And we want to know the name, the owner. We want to know the login of that owner. And then here we have something that's commented out that I'll demo in a second, which is the number of people who've started the repo. And then we want to know who posted it. And basically, this here is kind of an option that you can add if you want to know exactly what's going on with the query. And that's called notify on network status change. This is basically all you have to do here to fetch data and put it into your components. So you only have to initialize Apollo client once. And then for any component that you have anywhere in your app, you just decorate it with a GraphQL query, and you get the data right away. Now, we've already built this component so that when we pass in the stargazers count, it will actually show up. And now currently, that's not being fetched from the server because I commented it out. But if I comment that back in, and it saves the changes, you can see over here that the stargazers count actually shows up. I could now go to the GitHub repo and unstar it and start again. But I'm afraid if I do that, the demo will fall apart, and we'll all be very unhappy. So I'm not going to do that. And instead, I'll get back to our presentation. But you can try this demo out for yourself. It's on our website, like dev.apollodata.com. It's really awesome. Sashko built it in like 10 minutes, or maybe 20 minutes. I don't know how he does it, but things just happen, and suddenly demos appear. Anyway, we wanted Apollo Client to be universally compatible. So how do we do on that front? I put a bunch of logos here because if I put logos here, everyone will believe me, I hope. No, I think the measure of success here is how many people have built integrations for Apollo for different view layers. And we actually build none of these integrations ourselves. Now, I'm kind of cheating a little bit because there's a Redux logo here in the middle, and we kind of built Redux into Apollo Client because that's how the store works. But for all the other integrations, they were actually built by a community member. So we have React. React Apollo was first built by a community member. Now we maintain it. There's Angular Apollo. There's, for Vue.js, there's an integration. And there's an integration for Ember. It works with Next.js. There's examples for Expo. I think, to me, that was really satisfying to see that people just started, taking Apollo Client and building little integrations that make it much more convenient to use in those libraries. All right, next one, small and flexible. I don't know what your standard for small is, but we try to keep it as small as possible. So right now, and we run the script every time. So this runs on CI, and we make sure it doesn't go beyond a certain size. But right now, the gzip size of our bundle is 25 kilobytes, which is kind of tolerable. For comparison, I think React is 43 or so. So it's comparable. Right. Next point, inspectable and understandable. Actually, we had a hack week December last year or November last year. And Sashko, Danielle, and Glasser built a really cool thing, which is the Apollo Client DevTools. And they're kind of inspired by the Redux DevTools, if you've ever played around with them. So what the Apollo Client DevTools let you do is they let you look at all the active GraphQL queries, and they let you inspect the store that Apollo Client has, the normalized store. And I'll talk about that in just a second. But I'm actually also using this when I'm developing stuff with Apollo Client, and even sometimes when I'm trying to debug it, because it's really helpful for knowing, like, OK, what's in the store right now, which queries are active, which queries are not active. And another really cool thing that it has in here, which is probably my favorite part of GraphQL, it actually has a built-in graphical, which means if you click on that like second tab there, you'll get a graphical window. And if you run queries in there, it goes through the same network interface as the queries in your Apollo client. So if you're trying to debug a query, you're like, why is this query not working? Am I adding the cookies to it? Then very often, if you use graphical, you have the problem that you need to attach the same cookie or something, or you need to send some kind of token to your server so it'll get through to your API. Now here, with the Apollo Client DevTools, you can just put it like right in there, and the graphical will go through the same network interface that your client was used, or that your client used, so your website uses. And also, like in terms of making it understandable, Apollo Client has a pretty simple architecture. At the top, basically, is where you see your UI component, React Apollo. When that makes a query, all that Apollo Client does, depending on what you specified, is it will check if it has the data in the cache. If it does not have the complete data in the cache, it will make a query to the server, wait until the result comes back, and then it writes that in the cache. And there's a little thing that's now listening, because we made this query, that's listening to all updates for that query. And when that data is all in the cache, it will read it out, and it will piece the things back together, and then send it to your UI component. And the advantage of doing that is that if there are other queries that modify the same data that you're already watching, your UI component will get notified. So that kind of keeps your UI consistent. But we'll get to that in just a second. So how much time do I have left?
10 minutes.
OK. I can talk as long as I want. No. All right. So I just asked because this is actually the most difficult part of building a GraphQL client. So far, I think everything that I've told you could have probably been fulfilled with just a simple fetch client, right? You can make a fetch client that's community-driven, incrementally adoptable, super easy, right? Universally compatible. Well, fetch is pretty much universally compatible. If your app cannot use fetch, you have a problem. It's also simple to get started with, or it would be inspectable and understandable, and it would be small and flexible. So basically, we have 6 points on here that would be really easy to do if all we built was a fetch client. And now that I tell you that, maybe that's what we should have built, and we should have just told everyone it's amazing, and we would have had a lot of people using a fetch client just because we hyped it enough. But that's not what we wanted to do. So really, what do we mean by built for interactive apps? So I told you that the main challenge for interactive apps was UI consistency. There are people updating the app while you're looking at it. You want these changes to be reflected in your UI. For example, you're looking at your news feed on Facebook, or you're looking at the number of likes on something you posted. And we all try not to check too often, but if we post something that we really care about, we kind of want to see the number of likes, And I'm sure Facebook wouldn't like it very much if people kept refreshing the page. So thankfully, they kind of make that transparent. And so it just keeps updating. So you have updates that come from the server. And at the same time, you have updates that come from the client. So you might have an order form. You go to the second page. You click order. You come back to the previous page. You want that to be reflected as quickly as possible. And that's actually that middle point that I have there, which is optimistic UI. And sort of the challenges with UI consistency is the main reason why you want to have a cache in your GraphQL client that is normalized. If it wasn't for that, you could just fire off separate queries and everything would be fine. And so how does cache normalization really work? We tried to make it be as simple as possible, but it can get quite hairy. And as you'll see later, we actually also kind of tripped up a couple times while we were building this. So I guess that kind of explains then the experimental part of our GraphQL journey. But yeah, so here's an example of a graph. This is basically where the graph in GraphQL comes from, because your data on the server can be one really common way to look at it is that you essentially have a graph, right? People used to build things with SQL. I guess they still do. So you have a relational database. You define a relational schema, which means you have relationships between your tables. And actually, all your data comes together to kind of form a graph. And in this case, it's sort of a simple app where you have books and you have authors, and these have relationships, right? An author can have a name, an author can have a co-author, a book has authors, and it has a title. So all of these things, kind of like everything in the world, just is a connected graph, right? And what GraphQL helps you do is it helps you select data out of that graph, because there's no way that you can put all the data from your application on every single client. It would kind of be prohibitively expensive. And so what you want to do is you want to select part of that data from that graph. And GraphQL helps you select a tree out of that graph. So let's take, for example, a really simple query. You select a book, and you want to know the title, and you want to know all the authors of that book and their names. So what does that look like? Is you're essentially selecting a tree out of that graph. And the tree starts over there with the book, and it connects to two authors. It connects to its book title, and the authors kind of connect to their names. Now, if you kind of normalize that, what that looks like is you have a book. Points to the title, points to author. In this case, this one only has one author. And an author has a name and an ID. You can also select another book, and that book has an author, and that happens to be the same author. And so now you have a problem, because what you did is you have a graph on your server, and in that graph, you know all the relationships. But now suddenly you're starting to select trees out of that graph. And if you're not careful, you actually lose the information about those relationships. So in this case, you can still figure out that actually this author is the same person, right? And there's two ways that you can figure that out. Now, one way is, well, you know kind of the root of the query was the same. So your query took the same path in the graph. And so if it took the same path, this must refer to the same entity. In this case, like this is one way in which we can normalize the Apollo client store. So what we really want in the store is not a copy of each query, but we want a copy of each entity. And then we want to keep those, we want to remember those relationships. So let's see if this animation actually works. Yeah, so what you want to do is we want to take that author entity from both the queries and actually put it in the same place, so that if we run another query, for example, if that author changes, that it changes for both queries, right? There's actually a longer post on our blog written by Daiva, which I recommend. That explains all of this much better. So now let's take a different thing. So I just said, let's use the path to normalize, right? And so we had the thing that was like book, author, and we had the same book, because we used the same argument. And so we know that author thing should be normalized to the same place. But what if we actually queried from two different places in the graph? So let's say with one query you start from book, and with another query you start from author. Then we can't use the path to figure out that this author object was the same. So we need to use a different thing. And basically what we used is very much inspired by Relay. We just use a node ID essentially. But instead of prescribing the node ID, we just say like, well, you can provide a function and you can say how to generate the ID for your node. And a very common thing is if you have global unique IDs, you just use the ID. But another, like a much simpler way is if you don't have global IDs, which very often you don't. If you were using SQL, you probably just had an ID that was unique per table. So it's unique per object type, but it's not global unique. So you can use a data ID from object function that uses the type name and the ID. And Apollo client actually does that by default, so you don't even need to pass it that way. And now thanks to that data ID from object function, through which we pass every object before we normalize it, we know that it goes into the same place in the store, right? So we have this guy, Thomas Piketty, and he wrote 2 books. Or let's say he wrote The Capital, and we know he has ID 5. Now, if we select author with ID 5, we know that's still Thomas Piketty. And now if he goes and changes his name, he's going to have a problem because he's not going to be able to reprint all the books. But conveniently for us, we have a database, and so we can update his name. And so in our UI, it will actually show up consistently, even if we just query for the author. Now, OK, that was for simply running queries, right? But we also need to update the cache. And we're going to have to update the cache in just 5 minutes, because that's all the time that I have left. So when might you want to update the cache? A very common thing is you're running a query, or you're running another query, and the data has changed on the server. So you want to update your cache, and you want to have that show up in your UI consistently everywhere. Another common case is the user is actually mutating some data. He's changing some data. So for example, the user changes, I don't know, they change a post title. You want that to be reflected in that UI as quickly as possible. So you do something that's called the optimistic UI. But you have to do that on the client without knowing it from the server. Another example is when you have subscriptions and things are actually coming down from the server. So this was actually the most challenging thing that we encountered in Apollo Client. And it led to some very interesting bugs that we didn't initially anticipate. And it even led to a bug that, when we fixed it, caused people to say that we introduced a bug. And that's really interesting. So we explored a couple of ways for updating the cache. And we actually still have all of these ways in Apollo Client, because they're like, some ways are better suited for simple tasks, and some ways are better suited for complicated tasks. But we explored different ways, such as refetching. Let's say you have a mutation that inserts an element into the list. Or let's take, for example, the list of, what do we have? We had the list of repositories in the demo that I showed you. If you insert an item into that list, how do you know on the client that that list has changed, that there should be a new item? Because, right, you're just running a mutation that says create repository or like add repository. But there's no way for your GraphQL client to know that that item should actually go into that list, because that knowledge is not encoded on the client. It's only encoded on the server. So one way that you can make sure that your UI updates after you created a new item is by just refetching the previous query. So the developer hopefully knows that the list of repositories has to change when a new repository was added. So he can call refetchQueries. And here's kind of how that works in Apollo Client right now. You can pass it an array. Oh, I don't have a mouse here, so you cannot see what I'm showing. And I'm not going to walk over there. But you see, basically, you can pass it a query. You say refetchQueries, and you say the query update cache has to rerun. So basically, we're doing this when we're inserting a comment. When we're inserting a comment, we want to reload the list of all comments, which is what that query does. Now, that's kind of costly, but it's a really simple way to get started, right? You just specify, hey, when I insert an item, like, you might as well specify to reload the all queries. But if you want, you can just specify the individual query that you want to update. So that's refetching. But that's really kind of wasteful. And it actually requires the update to have already happened on the server. Now, if you want to do optimistic UI, that optimistic update never goes to the server. So you want to be able to do it on the client. What that means is you're going to have to be able to somehow write to the cache. And that's the thing that updateQueries lets you do. So in updateQueries, you provide the name of a query that's currently active. And you say, give me the previous result, and give me the result of the mutation. And I'll actually figure out what the new result of that query should look like. So in this case, we inserted a new comment. And so we want to get that new comment in the mutation. we want to get the previous result of the list of comments, and then we just call unshift and basically put that comment on the front of comments. Now that will work with updateQueries, and it will work with optimistic UI, and it will also work with the server result that comes back, which is really convenient. Another way is maybe you don't want to specify how the update happens in the mutation. Maybe you want to specify how that update happens in all the queries that you have, because maybe you just know that for your list of comments, you know which mutations update that. Instead of specifying with every single mutation which other queries it affects, you could specify with each query what mutations affect that query. And that's basically what reducer does. And so in reducer, you get the previous result of the query, and you also get an action that could potentially update that query. Now you look at the action, and is it an Apollo mutation result? Great. Was the operation name submit comment? OK, in that case, unshift your own comments. Now that helps you kind of concentrate everything in one place. Now, so far, so good. But the problem is, or the problem that we ran into, is that we thought, why would anyone ever have to update a query that is not currently active? And so we provided this convenient name, or convenient way of calling updateQueries. You just give it the name of a query that was active, and then it would update the cache, right? And we already have the query. We know all the sets of variables that that query was called with. And so we can run this update against all the values in the cache. And the same with reducer. But actually, it turned out people want to be able to update stuff that isn't even on the page. So those queries are no longer active, right? Maybe your user was clicking through lots of pages, and when the page isn't showing that component, you don't want the query to be active. But you might still want to be able to update the cache because the user might come back. And then you want to make sure you're showing them up-to-date data, or at least you refetch. So you want to know that that's not consistent. Now, when we initially designed these features, we didn't expect people to update things that were off the page. But they were actually using these features in that way because we'd forgotten to remove some expired queries from the cache. So everything was still in the cache, and the Apollo client was still actively watching those queries, which let people update data that wasn't currently in the cache, or that wasn't currently being shown on the page. And then when we actually cleaned up the list of queries and we fixed that bug, a lot of people came to us and they complained. They said, like, hey, wait a minute, I can no longer update things that are not on my page. And we said, like, well, I was never intended that way. It was a bug. It was not a feature. And then people said, well, we kind of like that feature. And so instead of arguing with people, which is never a good idea, we came up with a new way of updating cache, which we're pretty happy with and which we recommend that everyone uses now. And that's the update function. So the main problem with updateQueries was that it required you to specify a name of a query that you wanted to update. It's much better if you actually just provide the query string. And really what you want is you want to be able to imperatively update the cache. So you want to be able to say, hey, give me this part of the cache and update it. But you don't want to operate on the level of like individual nodes in the normalized cache, because that's kind of a nightmare. So what update lets you do is it lets you read data out of the cache. So you can give it a query, you read it out of the cache, and then you can modify that data in whatever way you want. You can add new data to it, and then you just call write query. And then Apollo client behind the scenes magically will apply this as an optimistic update if your response was an optimistic response. It will roll it back when the real response comes back, and it will apply the real update with the new data. And so now we have basically 4 imperative ways of updating the store, or like 2 ways, I guess. But you can call read query. You can call read fragment, in which case you need to provide the ID of a node, which means you can start at any place in the graph to select data out of it, or anywhere in the normalized cache. And then you can call write query, and you can call write fragment. And I think I'm way over time, so I'm going to skip subscriptions. Am I going to skip subscriptions? Yes, I'm going to skip subscriptions. All right, I'm probably also going to skip, almost skip what's next, but there's not much to say here anyway. So you just missed the subscriptions part. I just talked really quickly. But we're going to build next live queries. We're working on persistent offline storage. And then the one big thing that we're really working on is making sure that people can use one client on all platforms. So I was talking about the JavaScript client that we built, which we call Apollo Client, but we actually also have Apollo iOS and we have Apollo Android. And we're working on making all of those, or we're working on aligning the API of all of those clients. So when you have a mobile app, you can use the same persistent store in your mobile app, and you can run queries from React Native with the JavaScript Apollo client, write those to the same persistent store that your Swift client for iOS would write to, which means your app can have some views in React Native, and it can have some views in native, and they will use the same shared cache data, and they will work in a very similar way. Anyway, that's all I have for today. Yeah, thanks for being patient.